Hi, everybody, and welcome to this week's episode of Echo Live. We are going to be doing a pretty exciting experiment, and this is definitely a do not try this at home. Since it is Chemistry Month, October is actually the National Month of Chemistry, I thought what better way to celebrate than by doing some really amazing chemistry experiments right here live for you all tuning in on YouTube and Facebook. Now, I want to start out by talking about the gas that I used to fill up this balloon. Now, this is not a balloon filled with my breath. This is actually filled with a very important gas, one that we breathe in and kind of out all the time. This balloon is full of pure oxygen. Now, pure oxygen is not something that's easy to come by, which is why we're definitely calling this one a do not try at home, although you probably could not try this one at home episode of Echo Live. Now, there's a misconception about oxygen and what it has to do with fire. Lots of people think that oxygen on its own is a highly combustible gas. You would be correct in thinking that oxygen can be dangerous to work around flames, but oxygen on its own is not actually flammable. It's actually not the fuel that goes into a fire. Oxygen is what we call an accelerant, meaning that it lowers the temperature needed in order to ignite other substances or burn other substances in a combustion reaction. Just to prove that to you, I'm going to go ahead and put on some safety equipment. Since we said this is do not try at home, we definitely want to make sure that we are being safe. But our pure oxygen balloon, which you'll notice sits flat here on the table, it doesn't float like a helium balloon. That's because oxygen gas is heavier than the air we breathe in and out. And so this balloon actually sits nice and flat right here on the table. But in a moment, we're going to go ahead and we are going to try to ignite those oxygen gas or the oxygen gas inside the balloon. The way I'm going to do that is I'm just going to go ahead and use my handy dandy blowtorch here and bring our balloon very slowly into the flame, and let's see what happens. Here we go in 3, 2, 1. Now, my balloon definitely popped, right? But you didn't see any sort of huge explosion and definitely no crazy loud noise or anything that maybe we were expecting. So oxygen on its own, not combustible. And so we didn't necessarily get anything very exciting out of that reaction that I just showed you. But I figured we could make things a little bit more exciting and talk about the importance of oxygen in a combustion reaction. Now, inside this dish here, I've actually provided a different type of fuel. So in this dish here, I just have some cheese balls. So these cheese balls are actually going to serve as the fuel for my reaction. But it's actually really difficult to get these cheese balls to light on fire on their own. But that's where oxygen is going to come into play. Now, before we got started today, I filled up my handy dandy thermos here with some liquid nitrogen. That's super, super cold stuff, almost negative 321 degrees below zero. I filled another balloon with that oxygen gas, but you'll notice that my balloon has entirely deflated. Since we made the test tube that this balloon was stretched over really, really cold, it actually condensed that oxygen gas down into a liquid. Now, oxygen in its liquid form is very, very beautiful. You can see that really bright, very beautiful blue color of that liquid oxygen, which is all contained down here in the bottom of the test tube. Now, we're going to pour this entire container of liquid oxygen over our cheese balls, and that's going to allow us to lower the temperature needed in order to burn these cheese puffs right here on camera. Now, this is what we call a calorimetry experiment, because when we ignite these cheese balls, I'm actually going to drop this back down in my liquid nitrogen while I peel the balloon off the top, making sure we use as much of that liquid nitrogen or liquid oxygen as possible. But we call this a calorimetry experiment because when we use the liquid oxygen to burn our cheese puffs there, we are going to see the calories or the energy that is actually stored in this food. Now, humans need to eat, right, in order to live, and we also need oxygen in order to live. So we actually burn calories in the presence of oxygen inside our bodies all the time. And we're just going to show you what that looks like in a very extreme form right down here on the table. So we'll go ahead and zoom back in. In a moment, I'm just going to pour that liquid nitrogen all over my cheese puffs, and we are going to ignite it using the blowtorch. So here we go, our liquid oxygen going into the puffs and lighting them in 3, 2, 1. And definitely some energy being very quickly released from our reaction there. We saw that amazing amount of flame, and now we're just kind of burning the leftover cheese puff that's sitting in the dish. So snuffing out that flame so that we don't set off the fire alarm here at the Michigan Science Center. Not in the mood for an evacuation today. But that is the importance of oxygen in a combustion reaction. It allows us to lower the temperature needed. It allows us to release the oxygen or the energy from various foods. And that's a replica of the process that happens in your body all the time when we break down food in the presence of oxygen and use it for moving our muscles or firing the synapses in our brain. So thanks everyone so much for joining us for this week's episode of Echo Live. It is still chemistry month, so we'll plan to bring you even more amazing experiments for the next few weeks. Just a reminder that Echo Live streams live every Wednesday at 2:30 p.m. So you can always check out these amazing experiments here live or watch them after the fact. If there's something you'd like to see us try here on Echo Live, maybe something that you know is not safe to try at home, but you'd like to see us test it out here live on the show, send us a suggestion. You can send us a message, send us an email. We would love to hear from you. So thanks everyone so much for joining again this week. We hope we'll see you back here next week. And until then, have a great Wednesday.